Awesome, guys. All right, so if you want to hear about intents, something that I think everyone's going to be talking about a lot today, come listen. And since the Frontier guys are big on cake, we're going to be talking about Across's take on cake, because in many ways we are quite similar to them in their way they think about interop. All right, so what do we want? What we want is pretty easy, right? We want fast, cheap, and secure interop that is so seamless you don't even know that you're talking with blockchains. You just want it to work. And there's this sort of concept that people like talking about, that interop should be like TCP/IP. It should be like this base layer where like messages just flow between blockchains, easy, no problem, so simple, so like water, you don't even know what's happening. And I don't think I agree with this. Because in this model of interop like TCP/IP, we're sort of distilling the problem where bridging is just like sending a message. The formatting here changed a little bit, but it's just like we're going to send a message from blockchain A to blockchain B, and it's going to work. But we want to send this message quickly, cheaply, and securely. And this is like basically impossible to do. We might do it in 5 years with super fast ZK, maybe that happens. Maybe we get super fast, super cheap ZK interop tech. But otherwise, sending a message from A to B is not a simple thing to do. And let's, again, to do it securely too. Security, there's trade-offs here. If you want to make something secure, it's usually going to cost more or take some time. And so you just kind of think through these things, you're like, this is going to be a really hard thing to do. And so my answer is just stop sending messages. That's the problem. We're trying to do something that isn't very easy to do and that we should just avoid. And the observation here, this actually follows something Ankit said in his talk earlier too. TCP/IP is moving bytes. We're just moving data around this network. But blockchains are mostly, and I'll come back to this mostly, they're mostly moving value. And there's a lot you can do when you're moving value, and this has to do with like fungibility. And Ankit made the same presentation on his slides, or same point on his slides. He estimated like 95 to 99% of transactions that we care about are about moving value and not about moving bytes. And if that's true, maybe we can solve some of these interop problems and solve some of the UX issues by focusing on moving value. And the reason is that value is fungible. If I'm moving money, I don't really care about how the money gets there. I just care about the money getting there. It's fungible, and this is where my mental model for why intents works so well comes from. Is you are moving value, don't care how it gets there, you just want to specify the output. Don't care about the path, don't care about the execution, just want the most value at the end of the day possible. And if we're sending value and it's fungible, we can do fun things. Where we don't actually need to send a message to fill a user on an interop transaction. So stop sending a message from blockchain A to blockchain B, and instead have a network of solvers. We are in the solver layer of the cake right now. So instead of a network of solvers that are observing what's happening on blockchain A, so user deposit transactions, and are then filling a user on blockchain B with their own capital. And suddenly we get rid of this messaging problem, at least a real-time messaging problem. And so this is my take on why cross-chain intents are the future of interop. Here, with this intent concept, solvers can fill users with their own capital, and they can fill them quickly and cheaply, and then the solvers get repaid later. And it works. It sort of solves our dilemma that we started with. So, going into a little more detail, because it was pretty high level about just how this solver thing works. I look at, and I always have looked at, kind of the across system as something of a cake too, and it follows very nicely with what the Frontier guys are talking about. We got 3 layers. We got the intent layer, where the user is specifying what they want to do. And this might come from a front end, like the across bridge, across.2. It might come from a bridge aggregator. It's going to come from RFQ systems. And increasingly, I think it's going to come from applications themselves that are controlling user order flow. We then have a solver layer, and the solver layer is competing to fill the intent specified at the user layer. And then lastly, we have a settlement layer. And what's actually going to happen is the user funds are going to get escrowed in the settlement layer. The solver is going to fill the intent, and then at the end, after we verify the intent was fulfilled, the solver gets paid back from the settlement layer. That's how I think the future of interop is going to work, and now we'll talk about why. So the advantage here, intents can be really, really fast. This is maybe impossible for you guys to see on your screen, but this is across's median fill time from L1 to L2, from L2 to L1, from L2 to L2. And this is Stargate, and this is CCIP. And our median fill times on L2 to L2 are 7 seconds right now. 12 seconds for L2 to L1, 23 for L1 to L2. And we are 1 to 2 orders of magnitude faster than these other systems. And how is that possible? It's possible because we have these solvers competing on speed, and they can actually take finality risk. They can trust centralized sequencers, which is why the L2 times are so fast here. They can trust centralized sequencers and just fill users as soon as they get a pre-conf back. And even on L1, they can make probabilistic decisions where there hasn't been a 3-block reorg in a very long time. So 2 blocks, good enough. I can start filling users. And this is something that you can't do if you don't have these off-chain actors taking finality risk. You can't have a protocol. Chainlink CCTP absolutely cannot take finality risk. It's not worth it. So this is why intents are faster. Intents can also be really secure. And the idea here is that this architecture we have separates the interop problem into 2 parts. There's the urgent part, where users want their fast fill, and there's the complex part, where we communicate between blockchains and understand whether the intent was fulfilled and what's going on there. And by separating these 2, we've got a lot more options for how we do cross-chain messaging. The urgent part we talked about, the solver just fills the user with their own capital. And then the complex part, the messaging part, we can verify using any number of cross-chain messaging techniques. We can use the canonical bridges, the protocols write themselves. Even 7-day slow bridges is possible, just be a really long repayment time. We could write ZK proofs for proof generation. And because maybe we only need to batch aggregate repayments, so we can do 1 ZK proof for many intent verifications, or we can do optimistic systems. And that's actually how cross works. We optimistically verify batches of intents and repay them every hour or 2. And so we were able to solve for interop security without worrying about doing it quickly, which opens up a lot more options for how we can do this securely and cheaply. The third advantage is just cost. And the reason why this intent architecture can be so damn cheap, and again, you're not going to really see these numbers here, but it crosses L2 to L2 to L2, L2 to L1, L1 to L2. Across this costs here, this is all in gas and transfer costs over the last 90 days. Across can be really cheap because of 2 things we do. Instead of verifying each intent and having costs associated, messaging costs associated with verifying each intent, we batch them together in bundles, which we can do because the solvers are already making the loan. So these batches allow us to verify hundreds or thousands or tens of thousands of intents in 1 transaction. And then further, we can do optimistic verification, which is slow, but it's really cheap and quite secure. Add those 2 things together, and we have really cheap costs. The trade-off is that solvers are making short-term loans. So they're making loans of capital. We have a cost of capital we need to reimburse these guys for. But if we do the math, this trade-off makes a shit ton of sense. So here's my theoretical example, and I'll kind of walk you through it. Pretend we're bridging $50 million of volume a day. And we're going to do this over 25,000 transactions. So I've got a $5,000 average transaction size, 25,000 transactions. What does this cost me? Let's assume that we have a default cost. The user has to make a deposit, and then on the destination chain there has to be a fill. So there is going to be some gas costs that's unavoidable of the user deposit transaction and the destination chain fill transaction. But what are our verification costs? On the across side, with this intent bridge, we need to make loans for about an hour, and if you assume a 10% annualized interest rate, that $50 million of loans for an hour is $500. It's a small amount of money. It's kind of tiny. And then we've got to send a certain number of canonical messages in these batches to verify these repayments. And I'm estimating these canonical messages at something relatively high. Put a higher number if you want. I'm going to say these are expensive L1 messages. But we're spending like under $3,000 a day in our verification costs. And that's amortized over 25,000 transactions. If I send messages for each of these transactions, like something like what Stargate does, I've got to send a message 25,000 times. And even if these are like L2-based messaging and it's really cheap, I'm being generous here and saying this costs an average of $2. It's a lot more than that. It's going to cost you 50 grand. And so this trade-off here, where the cost of the loan is just not much relative to the advantage that we have from this batching, and we get faster speeds and better security. So when you talk about scaling this, across is this settlement layer that could scale to transfer $1 billion a day, but we're actually going to only send like 150 canonical messages because of this batching. And if you had a non-intent-based design, you'd be sending something like 10 million messages, which maybe that works, but that sounds expensive to me. And this is my reasoning why this TCP model for interop I don't think is the right one. I think the mental model is going to be more akin to a financial model where you are aggregating these fungible transactions and batch settling them. So our vision, and I think I'm over, so I apologize. Across the intent layer, we want to help build efficient RFQ and intent aggregation systems. One of the things that Ankit's Cake Frontier Research piece talks about is solver price competition versus solver speed competition. I want to research with this ecosystem RFQ systems that do both. How do we auction off intents to solve for both speed and cost? At the solver layer, I really want to establish a standard for cross-chain intents. Something that can get as many solvers and as big an ecosystem as possible, providing off-chain liquidity for this intent concept. And I think a well-designed standard here is purely positive sum for our ecosystem. And at the bottom layer, this is where I think across ultimately really lies, where across is this settlement layer that escrows user funds and releases them to solvers when these intents are verified. And our goal is to define to build this cheap, secure, and super efficient settlement system for these cross-chain intents. And so, looks like a cake, which is the theme of the day. And that is my talk, guys. So, thanks.